Hi, grade 9. So we're going to be moving on to chapter 8. We're not going to be finishing the rest of chapter 6 just because I think it's more important for you to learn chapter 8 than to learn the rest of chapter 6. So ignore the homework for today for chapter 6.4 or whatever it was, and just today we're doing lesson 8.1. So there's a handout on Teams that you should print and fill in as you watch this video. So 8.1 is optimum area and perimeter. So let's first start by reviewing what perimeter and area are. So if I have a rectangle, I would determine the perimeter by adding the length plus the width plus the width. If this is length and this is width, length, width. All right, area is the length times the width. All right, so let's just be clear on that before we get started. So at the top of your handout there, it says, Julie showed Wyatt and Nick a rectangular note card she made. So beside there's a diagram, and her rectangular note card is 6 centimeters by 6 centimeters. So that's really a square, but we're calling it a rectangle because we don't necessarily know the dimensions. So underneath that it says Wyatt wanted to make a card with the greatest possible area and the same perimeter as Julie's. Nick wanted to make a card with the same area as Julie's and the least possible perimeter. So there's a little chart there that shows area, perimeter, and then Julie's card, Wyatt's card, and Nick's card. So Julie's card is 6 by 6. So to find the area of her card, we would multiply length times width. So 6 times 6 is 36. To find the perimeter, we would add all the sides. So that would be 6 plus 6 plus 6 plus 6 is 24. Now, Wyatt's card had to have the same perimeter as Julie's, so 24, but it had to have the greatest possible area. And then Nick's card had to have the same area as Julie's, which was 36, and it had to have the least possible perimeter. So now we're going to talk about how we can find out what those greatest possible area and least possible perimeter are. So A says, outline rectangles on grid paper that have a perimeter of 24 units. Include some rectangles with sides that are not whole numbers. So a perimeter of 24 units means altogether the side lengths have to add up to 24. So I'm just going to write perimeter equals 24. Now, we're going to draw on that grid paper there some different rectangles. So we'll start with Julie's, which was 6 by 6. So count 6 squares. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so, and then we'll just label it 6 by 6. Right, so that one has a perimeter of 24. Now we're going to do 7 by 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So that's 7 by 5. Because 5 and 5 is 10, and 7 and 7 is 14. 10 and 14 is still 24. Now, what about if I do 4 wide and 8 long? 4 and 4 is 8. 8 and 8 is 16. 8 and 16 is 24. 8 by 4. We could do 9 by 3. We're still getting our perimeter of 24. We could do 10 by 2. Sorry, not easy to draw straight lines on here. 10 by 2, or we could do 11 by 1. And then some with sides that are not whole numbers, so maybe 7.5 by 4.5. So I'll start here and go to the end. 1, 2, 3, 4, 5, 6, 7.5. So this should be 7.5 by 4.5. All right, because 7 and 7 is 14, and a half is 15, and 4.5 and 4.5 is 9. 15 and 9 is 24. All right, now part B says determine the area of each of these rectangles. So I'll write the area in a different color. So for the area, we just need to multiply length times width. So 6 times 6 is 36. And don't forget that when you do area, say this was centimeters, then it would be centimeters squared, right? 7 times 5 is 35 centimeters squared. 8 times 4 is 32. 9 times 3 is 27. 10 times 2 is 20. 11 times 1 is 11. And 7.5 times 4.5 is 33.75. Right, so those are my areas. Now, part C says, what are the dimensions of the rectangle with the greatest area? So the highest number is 36, and the dimensions are 6 by 6, right? So they're the same. All right, let's do another different example. So part D says, draw rectangles with an area of 36 centimeters squared. So we could do 1 by 36. I'm not actually going to count this time. 1 by 36, so it's 1 wide and it's 36 long. We could do 2 wide and 18 long. Not counting again. We could do 3 wide and 12 long, because 3 times 12 is 36. 1, 2, 3, 4, 6, 7, 8, 9, 10. Or we could do 4 and 9. We could do 6 and 6. Because their area all has to be 36. Or we could do 4.8 and 7.5. And the way I got that number was I just did 36 divided by 7.5, and that was 4.8. So 1, 2, 3, 4.8. 1, 2, 3, 4, 5, 6, 7.5. Okay, and that was 7.5 by 4.8. All right, now E says determine the perimeter of each rectangle. So now I'm going to find their perimeter. So that means I need to add up all the side lengths. So 36 plus 36 plus 1 plus 1 is 74. 18 plus 18 plus 2 plus 2 is 40. 12 plus 12 plus 3 plus 3 is 30. 9 plus 9 plus 4 plus 4 is 26. 6 plus 6 plus 6 plus 6 is 24. 4.8 plus 4.8 plus 7.5 plus 7.5 is 24.6. All right, now on the back of the page, or the second page, it says, what are the dimensions of the rectangle with the least perimeter? So now we're looking at which one has the smallest number for perimeter, and that is the 6 by 6 rectangle again, right? So it's actually a square, and that had a perimeter of 24. That was the least perimeter. Now, G says, describe how you know that the dimensions you discovered are optimum measures. So that means these are the ones you want to go with, and that's because they're a square. So for a given area, a square produces the lowest perimeter. This is letter G on your handout. All right, letter H says, what was special about the rectangle with the greatest area for a given perimeter? So now when we're talking about greatest area, what was special about that rectangle? Well, the sides are equal. So it was a square again, right? All sides are equal. It was a square. And what was special about the rectangle with the least perimeter for a given area? It was also a square. I'm seeing a pattern. Okay, key ideas. Rectangles with the same perimeter can have different areas. the maximum area for a given perimeter will always produce a square. Rectangles with the same area can have different perimeters. The minimum perimeter for a given area will always produce a square. A rectangle with 3 bordered sides will always have a max area and a min border length where the 2 opposite bordered sides are twice the length of the other side. All right, so in this situation, you might say, there might be a word problem that says there's a building here and you need to fence in this area here. So there will only be 3 sides of fence because you don't need a fence against the building because the building acts as a fence, right? So you only need 3 sides of fence. So the maximum area and the minimum perimeter, because that's what we always want to find, is the biggest area with the smallest amount of fence because that's the cheapest, right? That will happen when this side, this long side, is 2 times as long as this side or this side, all right? So if the short side is X length, then the long side would be 2X. If the short side was 5, the long side would be 10. That's how you find the maximum area, the biggest area covered with the smallest amount of fence. Okay, so that's where you will use this type of information. Let me know if you have any questions with the homework questions, and I will try to help you as best as I can. And I hope you have a good day.